we're going to look at two examples. One example is going to be what we would say is in vertex form, and one's going to be written in standard form. Remember, when we look at something in vertex form is simply that ax minus h squared plus k. That should look very similar to what we saw whenever we were doing our transformations. The reason that this is called vertexes form is because I can easily identify the vertex. I don't really need to do much math because I'm going to describe it from its transformations. Okay, so in vertex form, I can describe that transformation. Remember, my A is going to reflect it, stretch it, shrink it. My H is going to move it to the right or to the left, and my K is going to move it up or down. So I can quickly describe this function, thinking back to our transformations. So here we're going to reflect over that x-axis. Here we're going to move to the right, 4. Here we're going to move up, 8. So now that we know those things, I can figure out where would that vertex be. Well, if I move to the right 4 and up 8, that vertex is now going to be at 4, 8. Just by knowing that it should have started at 0, right 4 would be adding 4, up 8 would be adding 8. Now, I want to be more specific about calling this vertex either a maximum or a minimum. So let's think about this. If I'm going to reflect, or if I have a negative A, then I know that this is going to be called a maximum value because it's going to open down. It's going to reflect and open down. So I can tell all of those things without doing any math. Okay. I can also determine that axis of symmetry, because remember we said the axis of symmetry is simply the x value of my vertex. So x is going to equal 4. So far we've done not hardly any math work here. As long as we remember what those transformations are, we should be pretty set. So the last thing that we really want to do here is we want to come up with our solutions, which is the same as saying our x-intercepts, which is the same as saying our roots, which is the same as saying our zeros. Okay, so all of these things, no matter what we call it, say that I'm going to set this equation equal to 0 and solve it. Right? If I had the graph of this, then I could simply look at where am I on the x-axis. But instead I have an equation. So remember we looked at intercepts before. Intercepts means that I'm going to find either an x or a y intercept by using the number 0. And I'm using the number 0 in my y because I'm looking for the x. So now what I want to do is I want to solve this to find what my zeros would be. So in solving this, I'm going to use my square root property because I see those parentheses. So I'm going to subtract my 8 here. Next thing I'm going to do is I'm going to divide by -2. So I get 4 is going to equal x minus 4 squared. Then I'm going to take my square root. Remember, when I take the square root, I get a positive and a negative. So the square root of 4 is +2 and -2. All right, then I'll finish solving here. I'm going to add 4 to both sides. So I'll get my two solutions are going to be 2 and 6. So now I have my solutions, x-intercepts, roots, zeros, any of those. It's going to be 2, 0 and 6, 0. So notice in vertex form, the only point that I'm really going to start doing any kind of math on is when I start finding those solutions or those x-intercepts, right? So let's look at it when it is in standard form. Remember, standard form is going to be that ax squared plus bx plus c. Okay, so in my standard form, I notice that I still have that same a, so I'll still be able to tell if it's going to open up versus if it's going to open down, which would tell me if I have a maximum or a minimum. Okay, so let's determine that. I see that I have a positive number out here, so this is going to give me a minimum value, which means it's going to open up. Okay. So it doesn't matter if it's a number, but I am concerned about if it's positive versus negative. Now though, if I want to find what the vertex value is, I need to use my formula. Remember, that's going to be the x value is going to be opposite of b over 2a. And then I'm going to take that number and I'm going to plug it in to get what the y value is. So let's do that. I'm going to have the opposite of 6 over 2 times 1. So I'm going to get negative 6 over 2, which would give me negative 3. So that is my x value. To get the y value, I'm now going to go plug that back into the equation. So I'm going to have negative 3 squared plus 6 times negative 3 plus 8, which is going to give me negative 1. So my y value is then negative 1. Okay, so on this one I had to do a little bit of work to find what the vertex was, unlike the last one that's in vertex form. Okay, now I can tell what my axis of symmetry is, because remember, it's just the x value that we found for the vertex, so it's going to be x equals negative 3. This time, to find those solutions, the x-intercepts, the roots, the zeros, I'm going to this time either choose between factoring or the quadratic formula. Again, it's still going to be set equal to 0, like the last one, but the method in which I use, I'm not going to use square root property anymore. So I'm going to factor this one. You could do it either way. So I'm going to factor, because I know that x plus 4 times x plus 2, 4 times 2 multiplies to 8, and 4 plus 2 adds to 6. So then I'm going to set each factor equal to 0. Right, remember when we solve by factoring, we factor and then we set each factor equal to 0. Then I'm going to continue to solve. So I get negative 4 as my x and negative 2 is my x, which means my ordered pair would be negative 4, 0 and negative 2, 0. So I can find all of those values, the vertex, the axis of symmetry, the solutions. I can determine if it's opening up or down, and I can determine if it's a max or a min from either a graph or from an equation.